going to get rolling with our second day in rational exponents. Again, not a replay of yesterday's. Just a little something where we get to add some fractions in with our exponents. But it's a good review up here at the top, too, especially some of you that were talking with me about, ooh, there's a lot of things to keep track of, and this is kind of confusing. And I can understand that with a first day in something. But here, let's kind of do some review again. When we're multiplying, okay, with like bases, so like here they're both 3, or like over here, if they were both a, that would be a like base, we're going to add their exponents. So here is where, if I need it, the calculator would come in handy. Now, to me on this one, I don't think I'm going to need it. I've got a common denominator. The numbers are small. So I'm like, okay, whenever we're adding with fractions, you want a common denominator. So we're going to leave that part alone. And then I just do 1 plus 3 for the top, but I can simplify it. So once I add those, I'm like, oh, well, 4 divided by 2 is 2. And then 3 squared again, not 3 times 2, 3 squared, 3 times 3 is going to be 9. And again, even though, I'll even show you, even though I could technically just pull out my calculator and go 3 to the 1/2. Notice my little cursor guy is still up in the exponent, so I have to pull him down by hitting the right arrow. Times 3 to the 3/2. Okay, you're like, why don't I just do that? Because like I was saying yesterday, there are going to be some problems in here, actually most of them, where we're going to have x in here instead. I can't do that on the calculator. So you've got to understand the rule. Now, it's a good backup to make sure you did it right. But otherwise, that's all we do there. Power to power. Multiply the exponents. Anytime you see things that are fractional, we like to make everything a fraction. At least I do. So I'm going to make that 2 a 2 over 1. And whenever we're multiplying with things like this, we're going to multiply straight across. So that would be 3 times 2 is 6. And we get our others. Thank you. Over 2. Which would be 4 to the 3rd. And 4 to the 3rd, again, 4 times 4 times 4, or if you're not sure, or just need to double check, we can always get that in there, but we want to get it to its most simplified form. That's going to be our big thing with these. Now, when I get to 3, I kind of have some choices. Since it's not always going to be a number, you could multiply those together since they're numbers. But since we're not going to be dealing with a whole lot with the numbers sometimes, we're going to go ahead and distribute. But let's think about one thing from yesterday for a minute. What exponent's on a number or a variable if I don't see one? 1. So when I'm doing these, I'm like, all right, so 1 times 1/2, ooh. 4 times 1/2, ew. I don't know. What's that going to be? Here's a hint, and again, we're kind of doing a preview of what's coming. Anything to the 1/2 power. Let's test this out here. 9 to the 1/2 power, is 3. Let's do that with the 4 for a minute. Maybe we can figure something out here. 4 to the 1/2 power is 2. So 9, 3, 4, 2. Now, where have I seen that before? Oh. Something to the 1/2 power is the equivalent of taking the square root of it. And again, we're going to be talking about that tomorrow, going back and forth between exponents and radicals. But for today, that'll get us hooked up. So here, what I'm really saying is I'm taking the square root of 9 times the square root of 4, which would then be 3 times 2, and I can get my answer. So again, lots of things from prior learning we're going to bring in, along with some of the stuff that's new. My Flippin property. Again, if something's negative, it flips the other side, same as the other way, and I'm going to add that in here. If my negative exponent's down in the denominator, I can flip it up to make it positive, just in case we run into that situation. So when I have 25 to the negative 1/2, okay, first thing, I want to flip it down to the denominator. Anytime we don't have anything in the other place, we just put a 1 there to hold the place. And now I kind of use what I just talked about here. This is really just 1 over the square root of 25. Or 1/5. So the nice thing about the numbers is it allows me to double check my answer on the calculator to reinforce what I'm doing. Again, I just don't want to become dependent on it. Okay, again, we talked about this yesterday. We always want to do bigger minus smaller with these. Well, 5 over 2 is bigger than 1 over 2. And if you weren't sure, here's how you can double check. You could do 5 divided by 2. 1 divided by 2. Well, 2.5 is bigger than 0.5 is. Okay, so I know that's my bigger one. So I'm going to have 5 over 2 minus 1 over 2. I do have a common denominator, thank goodness, even though we have a way around it if we didn't. Bless you. Keep my denominator. 5 minus 1 is 4. And now if I can simplify the fraction, I need to, and I can. And get to my answer. And so then our final one in the review, again, if I have an exponent outside of a fraction, I got to make sure that distributes to both the numerator and the denominator. This one's a little different. So we got 8 to the 1/3 divided by 27 to the 1/3. We haven't played around with this one as much yet. Again, we're kind of in preview mode here. If you take something to the 1/3 power, it's the same as taking the cubed root of that number. Now, here's our thing with that. What I'm going to give you once we start getting a little bit further is I'm going to give you a chart with your perfect cubes and squares on it. So you'll be able to reference that on something like that. But for now, what I'd just suggest, until we get there, is going ahead and using the calculator once you get the setup done. Whoops, that's not what I want. And getting to your answer that way. But once you have the chart, you'll be an expert at that too. And it'll go really well and make it kind of nice for you. Issues so far, because I want you to be able to kind of take this in for a second before I go barreling along into some of these examples down at the bottom. Nope, not too terrible yet. All right. So, as I come down a little further, okay, use the properties of rational exponents to simplify. Multiply. Multiply means I add the exponents, but this time I run into a little dilemma. Or at least I think I do at the start. I don't have a common denominator. Okay. I can't just say 1 plus 1 is 2, 2 plus 4 is 6, and write 2 over 6. It doesn't work that way. So if you're not going to find a common denominator, here's how you would take care of this in a fairly efficient way. Let me darken this a little so it's a little easier to see. Here I would take my 1/2, notice we're going into parentheses here, plus 1/4 in parentheses. Now, here's what we're not going to do. We're not writing 5 to the 0.75. No. Math, enter, enter. 5 to the 3/4. Okay? That's how our simplifying is going to work as far as this goes. And kind of look at it that way. So that'll be true on any of these. If you run into that dilemma, any calculator out there somehow will get you from a fraction like that into a fractional answer. I do it again here. Half of 2, because again we're multiplying. Half of 2 is 1. Then with my 1/3 and my 2, remember, I can always take the 2, and I said I was going to zoom after the last one, and then I didn't. Whoa, slow-mo. Okay. And turn the 2 into a fraction on that second one with my 5, and multiply across. 1 times 2 is 2. 3 times 1 is 3. And then I've got to stop and pause for a minute, because this is a situation we haven't come across yet. You're like, well, why don't I just add the 1 and the 2/3? Why wouldn't I? Okay, my base numbers aren't the same. If my base numbers aren't the same, I can't take this further unless I was trying to simplify. Okay, so this is actually as far as I can go, unless I'm being asked to evaluate it to actually find the numeric answer. Now, if they were both 8s, I'd add those together. If they were both 5s, I'd add those together, but not when they're different. So we're going to put one more note up here as we're doing this, just to remind ourselves. And I want to reiterate this again. We're not just doing these for me to have something for you to do for 20 minutes. These need to stay out. We need to try to use them at least as an example as we go. So, like for instance, we run into one like number 3. Looks real similar to what we did here. 4 times 1/4, if you're not sure. Get my calculator back on here. So 4 times negative 1/4 is negative 1. Why that's not darkening, but okay. It'll be the same with my 3. But I can't do negative exponents. We talked about that yesterday. We'll never have a negative exponent in an answer. So, I'll make these guys fractions. And then remember, to make a negative exponent positive, we flip it. So 1/2, or 1/2 to the 1, over 1 times 1/3. When we multiply, we don't need a common denominator, only when we add or subtract. So I can multiply across and get my answer. And we kind of start to see how this kind of connects with what we were doing yesterday. Same stuff, just now we're dealing with some of the fraction stuff. Not as fun, but hey. All right, we already said if we don't see an exponent, it's a 1. So now we're in division mode, which is where we subtract. 1 is a larger value than 1/3, so we're going to be doing 7 to the 1 minus 1/3. Again, I could find a common denominator. Maybe I already know off the top of my head what this is. Just keep remembering, if you're going to punch a fraction in here, parentheses is a good idea. Decimals, on the other hand, are not. Math, enter, enter. And get my answer. And so I just kind of keep looking at these. Or I look at number 5. You're like, wait, 5's a lot like 4 was, except now it's variables instead of numbers. Harty warned us about this. So here, again, if you're not sure, 5/6 and 2/3, I'm not sure which one's bigger here. 5 divided by 6, 2 divided by 3. 0.83 bigger than 0.66. So 5/6 is bigger. So when I go to do my subtracting, I'm going to do 5/6 minus 2/3. And to be honest, When you go to do the answer, you can do math enter before the decimal even comes up if you just want to get to the fraction right away. So again, math, that third button from the top on the left, and a couple enters. The key here is, do we know the concept to know, do I minus, do I add, do I multiply, and things like that. And you're like, why would he put 6 there? 6 looks just like 5. Here's my reason. Which is bigger, 3/8 or 1/4? 1/4, 3/8. 3/8 is. So what's that mean? That means when I do my subtracting, okay, I'm still going to do bigger minus smaller, just like we've been doing. So 3/8 minus 1/4, math, enter, 1/8. But where is the 1/8 going to go? The 1/8 is going to go with my y in the denominator. That's the key to doing bigger minus smaller. It tells me where the solution set's going to be. And there's this fancy concept called rationalizing the denominator with this. We're not playing with that. Get it into the right spot. We're going to be all right. I got a couple more I want to throw your way, and then I'm going to kind of let you do your thing here for a little bit after we do a little update into the worksheet. All right, number 9. Power to power, we're multiplying. Again, if you see a fraction, just make everything a fraction. It's going to make everything easier for you. So here, 2 times 4 is 8. 3 times 1 is 3. Let's just make sure that doesn't simplify anymore here. 8 divided by 3, math, enter. Nope, 8/3. That's good. If it would reduce down, I need to reduce it. But there's a couple easy ways to do that. And then finally, number 10. You're like, there's only one thing there. But it's got a negative exponent. We don't do negative exponents in answers. Flip that guy. He becomes positive. We're happy. Okay, that's our key with these as we're doing that. So here's kind of our game plan with this. And again, this is the note sheet. I forgot to label that. Oh, I didn't date it either. That's pretty bad of me. So make sure you label and date up at the top. But what you'll also notice up at the top is that on the worksheet it says we're going to skip 23 to 25. So let's get that taken care of. I know I'd written skip 4 through 6, but I did a boo-boo. It does happen. So if that's not crossed out on the back of your paper, it should be. But if it's not, do that. Because now there's all sorts of funny other stuff going on. So zap those 3 if they're not. What I want to do on the front is I want to get you a little bit of a preview. Again, homework. Get your date up there too. And we're going to get a little intro, just a little sneak peek into tomorrow in looking at 1 through 6. And then the rest of it is going to be real straightforward based on what we've been doing. So when it says write each expression in radical form. Again, we're just kind of getting a preview. If you leave 1 through 6 stuff until tomorrow after you've seen this, that's okay. But I'm going to do one of them in each of them just to let you see. So when we're doing radicals, a radical is just like a square root sign. When you look at that little exponent that's there, that's actually giving you information to be able to make a radical out of. The top value is going to be my exponent. So I'm going to put my k, and I'll put my 7 there with it. And then the number on the bottom is what's called our root. It can also be called an index sometimes. And all that means is it's the little tiny number that goes out here in my radical. Because it's not always a square root. It can be a cubed root. You might have seen those before. It can be a sixth root like it is here. But that's all we're doing is we're just kind of changing it back and forth and letting you see how that works. So even if I was doing it on number 2. So I'd go, all right, let's see here. My radical. Get my 3m. My base will always be underneath. And again, the number on top is the exponent that goes with it. The number on the bottom is our root or our index. That's it. So it really isn't going to be that bad even when we do start to see that. That's going to be the additional piece we're adding tomorrow to this whole thing with exponents. And then when I get to the bottom, it's doing just the opposite. Because remember, what we're going to do is we're going to take our base, okay, variables, numbers, whatever it is, and we're going to do exponent over root. That's how we're going to make it look like an exponential. So whatever it is that's underneath the radical, a single number, a single variable, or like in a case of number 4, 3p. Okay, there's my base. I see my exponent here. So that's going to be up here. I don't see a number for the root, though. So here's where this changes, because we're used to with exponents, it's 1. You know, a fraction, it's 1. With these guys, if you don't see 1 there, it's 2, because it's a square root. And I put my 2 in there. So no matter what these look like, again, there's my base. There's my exponent. There's my root. I'm good. Okay, so you get a little preview into tomorrow too. Not too bad of anything that's gonna jump us up and down here. So the rest of the worksheet is yours to kind of play with. Again, you've got a calculator. Do not let the fractions bite you, but keep the note sheet handy. Do not come to me with blank and go, once we see writing, we can work with something. Okay? But do take the time now to reinforce this so it doesn't go out of your brain. And we'll finish up stuff with exponents tomorrow.